All right, everything, the notes we covered today, we covered back in pre-calc, back in the spring.
Whoa.
So hopefully when we're covering it, it looks familiar and you'll start remembering things. Remember what
I mean, the PowerPoint itself
We
was
know how to do it.
All right, so we're looking at the derivative and the tangent line problem. Okay, we're going to use the tangent line problem to help us figure out what the derivative is. Now, what is a tangent line?
a line on the edge of a circle.
All right, back in your geometry days, it's the line on the edge of the circle. What was specific about that line?
It touched the circle.
It touched only one point. Okay, so we're talking about a tangent line that touches a curve at one point. But how else can I? Because I can draw a line that touches a curve at one point, but doesn't. But it's not a tangent line. So how doesn't? All right, that's one way to say it.
Yeah.
So I got a tangent line that touches a curve at one point, but does not cross the curve. Okay, something like that. Everybody know what we're talking about now? Garrett? So if I've got this curve and I'm going to draw a tangent line, my tangent line is going to touch right there, but it's not going to cross. Because I can draw a line that touches once, but that's not a tangent line. I want a tangent line that touches once but doesn't cross.
Like touches the edge.
Like touches the edge but doesn't cross. That's the difference between a tangent line and a line that intersects it. Clear on that? You should remember this.
I remember this.
What type of line is this one though? Remember the name of that line?
No, it starts with a C.
Starts with an S.
Secant.
Yes, that is my secant line. Okay? That's my secant line. The secant line is a line that goes through the curve and touches the curve at two different points. Okay, that's the secant line. And what we're going to do is we're going to start out by figuring out the slope of the secant line and then using that secant line to eventually get to the slope of the tangent line. Okay? So, what we need to see is as I move that dot on the right closer and closer to the dot on the left, I eventually get to where those dots are the same and I get to what type of line? The tangent line. So, what we need to do is we need to label a few things. So I need an x value for this point, and let's get an x value for this point right here. What would naturally be a label for this first x value? No. I want a label, I don't want a specific x value. No. A. And we're going to label this one B. Okay? Now, if these are my x values, what is the corresponding y value at this point?
A1.
No.
X.
How do we get y values?
F of A.
F of A, thank you.
Oh, I got a bonus.
And that means this y value is
F of B.
f of b. Alright. Now, remind me, if I've got 2 points, how do I find slope of a line using 2 points?
The difference between changing Y over changing X.
Change in y over change in x. Now, how do I represent, with what's up here, how do I represent the change in y?
F of B.
There you go. Change in y would be f of b minus f of a. And how do I represent the change in x?
B minus A.
b minus a. And yes, as Chris said, we also want to notice, or we want to identify, the difference between b and a. We want to think about that as h. So the difference between b and a is what is h.
So the top is the change in y and the bottom is the change in x.
Correct. Now, what has to happen? What has to happen to the x value of that point right there for me to get closer and closer to the tangent line? What has to happen to that x value? What has to happen to that x value to eventually take my secant line and turn it into the tangent line? What happens to the x value?
You have to subtract.
I'm going to move it. What's happening to my x value?
It's getting smaller. Closer.
But more precise, what is it doing?
H is getting smaller.
H is getting smaller, but what's happening to my x value?
Becoming less.
Right, but what is my x value getting closer and closer to?
A.
The x value of A.
H is getting smaller.
Okay, and yes, as I move closer and closer and closer, H is getting smaller. Now, when I get to my actual tangent line, what happens to H?
It disappears.
It goes away.
Vanishes.
So, using what we've learned in calculus this year already, this right here represents the slope of a secant line. What can I do to this thing to turn it into representing the slope of the tangent line? What has to happen?
Is that H equal to 0?
H needs, we said H needs, what needs to happen to H?
It needs to replace B.
It needs to go closer and closer and closer to 0. So what is it I'm finding? If I'm doing a limit as H does what? Approaches 0. So the first thing we want to do is we want to take this out and we want to put H down here.
That's for the slope of a tangent line.
Right now it's still slope of the secant line. What has to happen? What change do I need to make it the slope of the tangent line? What do I have to put in front of it? What do I have to put in front of it? The limit.
H equal.
So it's the limit of this thing as H goes to where? 0. Okay? So this right here, that part right there alone is what?
Slope of the
The
secant.
slope of the secant line. When I stick the limit on there, now I'm finding what? The slope of the tangent line. Okay? Now we need to kind of rewrite how we're saying things up here. And then when we rewrite it, you'll definitely recognize it. Alright? So, yes, what you guys should remember is this right here from last year. That is what's called, that whole thing together is what's called the limit. That's the limit of the difference quotient. And the limit of the difference quotient is the definition of the derivative. That is the definition of the derivative right there. The limit as h approaches 0 of the difference quotient. So that's what we
Difference
want to work with.
quotient.
Yes. Why is it called a difference quotient? Why is this thing called a difference quotient up here?
Dividing and you're subtracting.
I'm dividing, so that's where the word quotient comes from, and I'm subtracting, so that's where the word difference comes from. So that's why that's the difference quotient. But the difference quotient by itself is just the secant, and when I take the limit as h approaches 0 of the difference quotient, that is the tangent. Alright, that's the main thing we need to get straight. So, this right here, in terms of this up here, would be f of b. And why does it make sense that this is f of b?
Because B is A plus.
Because what did I do? What did I do with that h?
You added
I added h, which moves me out to the right. And then I have f of x, which is where I started at. So I'm taking f of b minus f of a. This is f of b minus f of a over h, which is the difference between my x values. All right, so let's do some problems with that. I have my function is f of x equals x squared plus x minus 3. My job is to find the derivative. And how do I find the derivative?
Use the difference quotient.
What do I do with the difference quotient?
Put a limit in front of it.
I take the limit of the difference quotient, and that'll give me the derivative. So first thing I want to do is write down the difference quotient, because we need to have that ingrained in our head. So every time you're doing something involving the difference quotient, I want you to write it down first.
Is it always approaching 0?
It's always approaching 0. Because what does h represent?
The difference
between A and B.
The difference between my two x values. And what do I want that difference to do?
It'll become nothing.
Go to 0. So yes, h is always going to go to 0. Now, I can go ahead and start working. Now, what do I replace f of x plus h with? What do I do to replace f of x plus h?
You put it as x plus h into x.
I put x plus h into f of x. So that gives me x plus h squared plus x plus h minus 3. And then f of x is just what I originally started with, which is x squared plus x minus 3.
A bunch of things.
Now, if you remember, what I need to do is I need to distribute everything in the numerator, and after I distribute everything, what should happen in my numerator?
Cancel.
What should cancel out?
No,
X.
X.
Everything that doesn't have an x. Remember that from last year? Everything that doesn't have an x should go away. So let's go ahead and multiply and distribute first. So that gives me x squared plus 2xh plus h squared plus x plus h minus 3 minus x squared minus x plus 3. And again, in my numerator, if it doesn't have an h, there should be something up top that cancels it out. So x squared doesn't have an h, so it cancels out. This has an h, that has an h, this doesn't, so it should cancel out. That's got an h, this doesn't, so it should cancel out. So then, after I get rid of everything that doesn't have an h in it, what should happen? I'm going to do two things in one step.
Factor.
Take the h out and cancel it with the h in the bottom. So if I take the h out and cancel it with the h in the bottom, that leaves me with 2x plus h plus 1. Now I'm going to stop right there, make sure everybody gets caught up, and make sure everybody understands what we did. Everybody understand where the plus 1 comes from?
No.
H divided by H.
Because right here, I've got 2xh plus h squared plus h. And if I'm going to factor something out is the same thing as doing what? Dividing by what I'm taking out.
Oh, yeah.
So if I divide by h, that gives me 2x. If I divide by h, that gives me h. If I divide that by h, that gives me 1. So that's where the 1 comes from. Now, as with all limits, Jasmine, as with all limits, as soon as I cancel, what do I do next? I plug in. And I'm plugging 0 in for h. When I plug 0 in for h, that gives me 2x plus 1. Now, what does 2x plus 1 represent? No. That's the derivative. That is the derivative. Now, here in a second, we're going to have to get the slope of the tangent line, and we use the derivative to get the slope of the tangent line. What's the next step I have to do to get the slope? They have to give me an ordered pair, and I take the x value from the ordered pair and plug in, and that gives me the slope at an exact point. That's what happens. But the first thing we want to do is be able to get the derivative, which is this right here. All right, again, I'm wanting to find the derivative, so what do I need to start with?
The difference quotient.
Not just the difference quotient,
The limit
the limit of the difference quotient.
Write it down.
It's two for everyone. That's where it says add anything on the bottom yet.
All right, so the limit as h approaches 0, f of x plus h is 3 plus 2/3 x plus h. And then minus f of x would be 3 plus 2/3 x. And that's all over 8. All right, Melly, what do I want to do next? Distribute. Good. Distribute. So that is 3 plus 2/3 x plus 2/3 h minus 3 minus 2/3 x. And that is all over h. Darius, after I distribute just like I did, what should happen in my numerator? Cancel everything that doesn't have an h. So that means this 3 should go, which it does. It means this 2/3 x should go, which it does, and that leaves me with 2/3 h. And at this point, I can go ahead and cancel my h's, and I get the limit as h approaches 0 of 2/3. And as we all know, I am now trying to take the limit of a constant, and we all know the limit of a constant is a constant. So that means my limit is 2/3. Now, so what did I find in 2/3 again?
Derivative.
That's the derivative, but in this case, it's also
The slope
the
of the
slope
tangent.
The tangent.
of the tangent line everywhere. All right, on the next one, we're going to find the slope of the tangent line, and then we're going to use that to write the equation of a line. All right, so this time I've got my function, which is 1 over x minus 1, and we want to find the derivative, but we want to also find the slope of the tangent line, and then we want to find the equation of the tangent line. Right? But where do I need to start, Cole?
Writing down the difference quotient.
Not just the difference quotient.
The limit.
The limit of
The
the
limit
difference
of the
quotient.
difference quotient.
Because the difference quotient just gives me what?
The
Slope of the secant line.
The slope of the secant line. Good. So there's that. And we apply it to this particular function. That gives me 1 over x plus h minus 1 minus 1 over x minus 1 all over h. Make sure you're good with me there.
Ooh.
Now, Garrett, we should notice that I'm now dealing with what?
A fraction within a fraction.
Which tells me to do what?
You get a common denominator.
And do what with it?
Multiply it out.
Multiply, good. If there's one thing I want you guys to be able to do before you leave Carl Albert, it's to realize that if I have a fraction within a fraction, I need to multiply top and bottom by the common denominator. That will make me so proud.
I'll break it out to your 58. You see this
Because
difference?
if you can handle fractions within fractions, that's awesome.
Whoa.
Alright, so I'm taking that times my first fraction, and I end up with just what?
1.
No.
X minus 1.
X minus 1. I take that times my second fraction. I end up with x plus h minus 1. Do I want to multiply everything in the denominator? No. Because what do I want to eventually happen?
You gotta throw
Cancellation.
What has to cancel?
H.
The h has to cancel.
Cancellation.
So I'm going to leave it. Alright, at this point, what happens in my numerator? It doesn't have an h, it goes away. So that means x and x go. -1, that actually turns into a +1. What's left in the numerator?
8.
Negative h.
I'm going to distribute that negative.
And I can go ahead and cancel that h. So I'm ending up with just -1 over x plus h minus 1 times x minus 1.
Plug H
I plug what in?
0.
Plug 0 in for
8.
the h, and what do I end up with?
X
in.
minus
Negative 1 over X minus 1 squared.
And what is it that I just found? And I have found the derivative. But we're not stopping there on this problem.
Oh, no.
We want to find the actual slope. So what do I do to find the slope?
Plug in the
Plug 3
X
into
value.
I plug in the x value into x. So if I plug in 3, 3 minus 1 is 2, 2 squared is 4, so that means my slope is
Negative 1.
Hold on, I need to get that. I need to write that out.
my slope of the tangent line at the point 3, 1/2 is -1/4. But we're not going to stop there either. We're going to write the equation of the tangent line.
Oh, yeah.
So, what am I going to use to write the equation of my tangent line?
Slow.
And my point, but what?
Point slope formula.
Thank you.
Well, we all just.
And this is something that we need to have burned into our memory. Alright, because we need to be able to write the equation of a tangent line very quickly. And I can guarantee you it's going to be on a free response question. You get a point just for being able to write the equation of a tangent line. Easy.
Is that it?
Okay? So that's what I want to start with, and now all I got to do is plug all my information in. So it would be y minus 1/2 equals -1/4 x minus 3. So I did 3 things on this problem. What was the first thing I did?
Found your derivative.
Found the derivative.
Then you found your slope.
Then I found my slope.
Then you found your slope function.
Then I wrote the equation of the tangent line.
Do whatever. So what would your answer be on this problem?
Well, depends on how I asked it. If I just wanted the equation of the tangent line, then this is my answer. If I asked you for the derivative and then the slope and then the tangent line, then there'd be 3 different answers. Last thing we need to do is use something called the alternative form of the derivative. Alternative form. And it looks like this. It's actually easier.
Can this be used on?
I'm getting ready to tell you when it can be used. Now, what we've been doing is we've been using the limit of the difference quotient to find the derivative. And then once we found the derivative, if I wanted an actual slope, they had to give me a point. I plugged the x value in to find the slope. Okay? If the problem is only wanting the slope of the tangent line, this is the way to go. So I can only use this if I'm wanting to end up with the slope of the tangent line. If I want the derivative, I can't use this. Okay? If I'm looking for just the slope, I can use this. Everybody okay with that? Good. So here's the problem we're going to work. So what is it this problem is wanting me to find if they're giving me f of x equals x squared minus 5 and they're giving me c is 3?
Slope.
They're wanting me to find the slope of the tangent line where? What type of value is c equals 3? It's an x value. Okay? So they're wanting me to find the slope of the tangent line of x squared minus 5 at the x value of 3. Okay? And all I've got to do is plug in. Okay, so I'm putting 3 in for c. F of x is x squared minus 5. What do I do to find f of c?
Plug C into F.
I plug c into f, so I'm plugging 3 into f. So what do I get when I plug 3 into f?
4.
I get 4. Because 3 squared is 9, 9 minus 5 is 4. And then on the bottom, I just have x minus 3. So then I have the limit as x approaches 3. On the top, I'm now dealing with x squared minus 9 over x minus 3. So you should be seeing what's happening.
X plus 3, x minus 3.
X plus 3, x minus 3, what's going to cancel? So that just leaves me with what? That just leaves me with x plus 3.
You plug it in.
And I plug it in, and I get 6. Now, what does 6 represent?
I don't know.
Nope, it's not the derivative.
Tangent.
This is the slope of the tangent line where? At the x value of 3. Now, I'm going to take it further, and I'm going to ask you to write the equation of the tangent line.
Okay, so then you have to write down.
So, y minus y1 equals m times x minus
x1.
x1.
Y
So, I need y minus my y value.
6.
No.
Did they give me a y value?
No.
But I need to find the y value. How do I find the y value?
Why are you plugging 3 back in?
Plug 3 in where?
The original.
Into the original function.
You get 4.
So I plug 3 into the original function. 9 minus 5 is 4. So that means my y value is 4. Now, here's something that needs to also be burned in your head. Anytime you are needing a y value, where do you go?
The original.
The original function. Let me say that again. Anytime you need a y value, you always go back to the original function. Let me say that one more time. Anytime you need a y value, you always go back to the original function. All right, so my slope is 6, and my other x value is 3. Now, when can I only use the alternative form of the derivative?
Just
When we're finding the
When I'm
slope.
finding the slope. If I want the derivative, what do I have to do? I have to use the other one, the limit of the difference quotient. Okay, and this one actually is still the limit of a difference quotient. Why?
Because you're using X and C.
What's going on the inside again?
Uh,
Subtracting on top and bottom, which is your difference, and I'm dividing, which is your quotient. So this is still a difference quotient. This is still the limit of a difference quotient. It's just the alternative form. So when we're talking about the alternative form, this is what we're talking about. And again, Melody, I can only use the alternative form when I'm wanting to do what?
Find the slope of a tangent line.
Find the slope of the tangent line. If I need the derivative, I have to use the original. Right, and what does the derivative represent?
The way to get the slope.
All right, be more
Change
mathematical
between
than
secant to
Well,
tangent.
the equation to get the slope?
of the tangent line. That's what a derivative is. Derivative is the function that will allow you to find the equation, or to find the slope of the tangent line.